Alright, so in this video we're going to cover problems 9 through 13. Number 9 says identify as exponential growth or decay. We're going to go ahead and answer the questions first. So it says, what are some characteristics of exponential growth? Growth is when b is bigger than 1. Decay is when b is between 0 or 1. Or kind of in layman's terms, if b is a fraction, it's decay. If b is a whole number, it's growth. B is the piece in parentheses. So that's my B on every single one of them. That's what we're looking at. So this first one here, I'm not going to explain this one, too ridiculous. That's decay because b is 1/4. Growth because b is 4. Decay because b is 1/3. Growth because b is 2. And growth because b is 3. So if b is a fraction, it's decay. If b is a whole number, growth. Here we're asked to solve for x. So again, hopefully we know this by now, but anytime I ask you to solve, I want you to end up with x equals when you're finished. So here to solve and get x equals, we need to get x by itself, which the first thing we need to do that is get rid of my square root sign. Well, the only way to get rid of my square root sign is to square both sides. Now with the square root sign, squaring this left side just gets rid of the radical sign. So it gets rid of the square root. So we're left with x plus 3. And then over here we have x plus 1 squared, which x plus 1 squared means that x plus 1 happens twice, which means when we solve this, we need to distribute. So after you distribute, you end up with x squared plus 2x plus 1. Anytime we see an x squared, we need to be thinking one side needs to be 0, and then we can either factor or use the quadratic formula. Again, since this is a multiple choice test, I also suppose you could graph this in your calculator to figure out the solutions. But here I'm going to factor. When we factor, we need two numbers that multiply to 2, negative 2, and add to 1. So that's going to be x plus 2, x minus 1, which means that x equals negative 2 and positive 1. And x equals negative 2 and positive 1. Again, with square roots and rationals, you need to check for extraneous solutions. If we plug in 1 for x, 1 is going to work. So this is correct. If you plug in negative 2, you're going to get an equation that's not true. You're going to get an equation that says the square root of 1 equals negative 1, which is not true when we're solving. So negative 2 is extraneous, so negative 2 is no good. So our answer there would only be the positive 1, not the negative 2. And again, if you graph this in your calculator to check for solutions, or if you plug the x of negative 2 back into the equation, it's not going to give you a true statement, which is why we exit out. And if you see the word extraneous, that's what it means. It's an answer that you solve for algebraically that sounds like it works, but it actually does not. So at number 11, again, it asks us to solve for x, so we know at the end of the day I am looking for x equals. On the left side of my equation, I immediately see I have two logs. Anytime that we're solving and one side of the equation has two logs, I know that I need to condense those logs into a single log. When we're condensing, if two logs are being added together, we take the inputs and we multiply them together. The inputs of the two logs on the left are 4 and x squared. So we're going to take 4 and x squared, and when we condense these two log base 2's to one log, we're going to multiply 4 and x squared together, which in this case is just going to mean right up next to each other, which gets me here. Well, now we have log base 2 of 4x squared equals log base 2 of 16. Well, the definition of an equal sign means that we have to have the same thing on both sides. So if I have log base 2 of something equals log base 2 of something, those somethings have to be equivalent, which just means that we get to say that 4x squared equals 16, because whatever the two inputs of the logs are on either side have to be equivalent. They have to be the same for this to be true. And then this, we just got to solve for x. So x squared equals 4. And then we got to take the square root of both sides to finish getting x by itself. So x equals plus or minus 2. Remember, with logs, you need to be careful and check for extraneous answers, because we cannot take the log of a negative number. But here, the only x, or the only time we're going to plug in that negative 2, that value is being squared. So since that value is being squared, we're going to be fine with negative 2. Well, I don't really know what just happened to all my writing, but my iPad glitched and it disappeared. So just rewind if you need to see that writing again, and it'll pop back up. So here on number 12, it asks us to identify all vertical and horizontal asymptotes for the graphs of x cubed over x squared minus 9. Horizontal asymptote, if you recall, are the rules that pertain to the degree of the numerator and the degree of the denominator. So hopefully we have those written down somewhere. But the first one, if the degree of the top is bigger than the degree of the bottom, which in this case is true because the degree of the numerator is 3, the degree of the denominator is 2, because by degree we mean highest exponent. If the numerator is bigger than the denominator, then we do not have a horizontal asymptote. And on the second one, if the degrees are the same, which the degree of the numerator and denominator here are both 1, because you just have an x. If the degree on the numerator and denominator are the same, then we divide the coefficients, which just means we divide the numbers in front of x, which in this case, in the numerator and denominator, the number in front of x, or the coefficient of x, is 1, which means we're going to have a horizontal asymptote at y equals 1. And it's y equals because horizontal is a flat line. Vertical is x equals because it's a vertical line, hence the names. Vertical asymptote is any value of x that makes me divide by 0. So in the first one, we have x squared minus 9 is the denominator. So if x were to be 3, I would get 0. Or if x was negative 3, I would also get 0. Because 3 squared is 9. 9 minus 9 makes me divide by 0. Negative 3 squared, also 9, minus 9, also gives me 0. So we have two problem values on the first one that would both make me divide by 0. The second one, again, it's any x value that makes me divide by 0. So the denominator of the second fraction, or the second problem, I mean, is x plus 6. So if x was negative 6, we would have an issue. So my vertical asymptote is going to be at negative 6. So horizontal asymptote, you need to follow the rules that you hopefully have written down in your notes somewhere. If not, you can go back to the Edpuzzle video that pertains to that and watch it again. Vertical asymptote is any x value that makes me divide by 0 when I plug it in. Number 13. Number 13 says if m is x to the 15th, what is the cubed root of m? It's just a really fancy way of saying what is the cubed root of x to the 15th. There's a couple different ways we can do this. I'm just going to go the simplest way, or what I consider to be the simplest way. We're going to rewrite this in radical or exponential form, so it's currently in radical form. And we want to write this radical form using the radical property with a rational exponent. So if we remember that property, rational exponent, I just mean a fraction. So the number outside the house, or that 3, the cubed root goes in the bottom of a fraction. The exponent that x is being raised to, in this case 15, goes on top of the fraction, which means this simplifies to x to the 5th power. So that'd be my answer. So when we see this radical business, I would rewrite it with the rational exponent using the radical property from a few tests ago, the log test, or the exponent property test. And rewrite it using that, and then just simplify. And again, all these are multiple choice, so hopefully we'd be able to identify the correct answer. All right, I'm going to scroll down. Pause it if you need the work there, or just rewind. All right, so now here we have 14 through 17. 14 says the radius of a sphere in relation to its volume is represented by the beautiful equation shown below. Determine the volume of a sphere with a radius of 1.375. So that's a bunch of words that say plug in 1.375 for R and solve for V. So we're going to go down here. We're going to plug in 1.375 equals the cube root of 3V over 4 pi. And here we're trying to get V, so I need to cube both sides to cancel out my cube root. And if you cube 1.375, you get roughly 2.5996, and that's being set equal to 3V over 4 pi. And then again we're trying to get V by itself, so it's in the numerator of a fraction, which means I need to get rid of the denominator of the fraction. And to move 4 pi from one side of the equation to the other, since it's in the bottom of a fraction, we need to multiply by 4 pi, which will cancel that out, which means I have to multiply this side by 4 pi. And if you just type that in your calculator and do 4 pi times that rounded decimal there, you get 32.668 roughly, which is equal to 3V. For those science fans out there, in the original question it gave me 3 decimal points or 4 sig figs, so we'll just keep using our 3 decimal places. I guess I'm not really following significant figure rules, but we'll just keep 3 decimal places. So it's equal to 3V. Again, if we want to get V by itself, now we got to divide by 3. So V equals roughly 10.889. Beauty of our semester exam is this is also a multiple choice. So if you completely blank on how to do this, you can plug in A, B, C, and D for V and see which one comes out to pretty close to 1.4. Because they're not going to be close enough that you're going to struggle to figure out which one's the rounded answer. On to 15. 15 here asked me to graph. Luckily, we go to Byron Nelson High School, so we have the capability of having a yellow calculator that can graph for us. But when we're graphing this on the review, I will graph this without technology. So graphing a logarithm, we can't take the log of a negative number, which means that at the h value, the h value is what gives me 0. So at that h value, we're going to have a vertical asymptote. So if you look at this, it's log base 3 of x minus 1. So my h value is positive 1. So we're going to have a vertical asymptote at 1. I guess I said I was going to use technology. I'm not going to go over the reference points in the videos because I didn't teach it to you like that in class. So if you use your calculator, there's a pretty point at 2,2. Which if you want to know how to do this without a calculator, just come ask me and I'll tell you. 2,2, and then there's another pretty point at 4,3. 1, 2, 3, 4. And then a log graph curves this way and then approaches the asymptote at the bottom. So on the test, you will have a graph probably and be asked to pick the equation that matches, or they'll give you an equation and say which graph matches it. The key thing here is to know or be able to read on your calculator that the vertical asymptote happens at the h value. All right, 16. 16 says the function f of x is blah, 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 and where is the whole located? So the removable discontinuity or whole is we factor the numerator, we factor the denominator, and any factor that cancels out in top and bottom creates a hole in my graph, or an open circle if we actually graphed it. So here we need to factor the top. So I'll try to write this every step. X squared minus 3x minus 10 over x squared minus 4. That's going to turn into, if you factor the numerator, I need two numbers that multiply to negative 10 and add to negative 3. So my options are 10 and 1, which are not going to add or subtract to negative 3, or 5 and 2, which we can get negative 3 out of. Since b is negative, the bigger number needs to be negative. So it's x minus 5, x plus 2. And on the bottom, we have a difference of squares. So x is plus 2 and minus 2, two numbers that multiply to 4. And when I add them, go to 0, so it's 2 and negative 2. Hopefully we see that we have an x plus 2 on top and bottom. So boom and boom. Which means the x value of where the hole is located is negative 2. So my hole happens at negative 2 comma y value. And to find y, if you know the x value, to find y you need to plug y in to what's left over. So here, I'll go down below, I won't go next to it. So we're left with x minus 5 over x minus 5 divided by x minus 2. We're going to plug in negative 2 because that's the x value of the whole. And we're trying to find the y value that goes with it. And when we do that, we get negative 7 over negative 4, which since they're both negative, will actually make them both positive. So my whole would be negative 2 comma 7 over 4. So when you're trying to answer a whole question, factor the top, factor the bottom, anything that cancels out is the x value of the whole. Since it's multiple choice, that's probably going to be good enough, just identifying the x. But to find the y that goes with it, you need to plug in the x value that you found back into what's left over. If you plug it into the original, it's not going to work. That's why it's called a hole. If you plug it in, your calculator is going to say error. So you need to plug it into what's left over after you cross out that factor and then see what y value corresponds to that x. Number 17 asks me to expand. So we're back to logs. When the inputs of logs are being divided, when we separate those logs, when we break those apart, we need to put a subtraction sign in the middle. This entire time we're going to have log base 3. I'm never going to mess with that. So we have log base 3 of 5m squared minus log base 3 of n, because 5m squared was the top of my fraction, n is the bottom of my fraction. So when we break up those logs, we're going to put subtraction in the middle. Now we need to break up 5m squared, because both of those, that's two different things. I have a 5 and I have an m squared, so we can expand that first log more. So we have log base 3 of 5. And when we have two inputs, 5 times m squared, when we have two inputs being multiplied, when we break those logs up, we add in the middle. And then I can't do anything to log base 3 of 5, so that's going to stay. Exponent property means this exponent can come out front of my log. So this is all three properties in one question. And then that's going to be my final answer. So logs, if the inputs are being divided, break up the logs and put subtraction in the middle. If the inputs are being multiplied, break up the logs and put addition in the middle. Alright, I don't want this video to be too big or it won't fit on Edpuzzle, so I'm going to stop it here and then go on to the next video.